So when you're writing your end behavior, we have on the left side, x approaches negative infinity. What is f of x doing? And then on the right, x is always positive. What is f of x doing? So go ahead and fill that in, and we'll talk about the end behavior. Yes?
Is the coefficient in front a 3?
Okay, so the coefficient... Wait, what are you talking about? One more time. Are you asking how I got the degree?
Yeah.
Oh, okay. So to get the degree, I added 2 plus 1, and that equals 3. What happens if the negative 3 had an x? Then we would add 1 plus 2 plus 1. Yeah, we're adding your exponents, but not your constant. The constant doesn't count as a variable.
So in this case, would you add your degrees before or after you factor? Well, not in this specific case, but
Oh, you trying to get?
an equation.
I would take out the GCF first, and then I would factor. Okay, so because this is negative, this tells me what the right side is going to do. Because this is negative, on the right, it's going to go down. So I'm going to add negative infinity right here. So the right side tells you the leading coefficient, and we're going to have a lot of practice with this today, tells you what the right arrow does. And the degree will tell you what the left side is going to do. So the left side is either going to do the same or it's going to do opposite. So what do you think it's going to do? Is it going to be the same or is it going to be opposite? Opposite. So instead of it going down on the left, it's going to do the opposite, which would be to go up. So we're going to do some more. So the first step, so now let's look at question B, because we're going to do a lot of these today. And we're graphing two functions also. So your zeros, again, I'll give you a minute to go ahead and copy down this side. Did you copy this down yesterday?
No.
All right, go ahead and copy down this side. Okay. So we have these factors will determine where our zeros are. Okay, so we're going to set the x plus 1 equal to 0, the x minus 3 equal to 0, and the x plus 5. So I have 3 x-intercepts, -1, +3, and -5. Your degree, we're adding, not including this 2. Okay, we'll talk about what that 2 tells us. But because that 2 doesn't have an x, it doesn't get to add to our degree. So we have a 1, a 1, and a 2. So I'm going to add 1 plus 1 plus 2. What is 1 plus 1 plus 2? 4. And 4 is 4 even or odd? So when I talk about my end behavior, because it's even functions have arrows that go in the same direction. So when I write my end behavior, instead of writing it separate, I mean, you can technically always write it separate. You can do left and right. But anytime it's even, what I usually do is write it as one statement. So it would be as x approaches positive and negative infinity, my y value is either going to go up or down. And this tells me if it goes up or down. So is this 2 positive or negative? Positive. So this is both arrows will go up. So now go ahead and glue down that cutout that you picked up. For some reason, some of them this does not show the title is super gray, and some of them do. So if you want to write the title on top of your cutout, it just says end behavior of a polynomial graph. I mean, you could just write end behavior. We know what it is. So when we look at this graph, notice that anytime it's even, when it's even, arrows are the same. And when it's odd, the arrows are opposite. And these are the end behavior statements. When I think about end behavior, again, I always determine is it positive or negative. So these first two, the first one represents a positive leading coefficient, and this is also positive. Notice that on the graphs that are positive, the right arrow is going to go up. The degree will tell you if the left side is going to do the same thing or if it's going to do the opposite. So these two have a positive leading coefficient, and these two have negative leading coefficients. So if you know those two things, if you know the degree and if it's positive or negative, you should be able to write an end behavior statement.
Are you in the quadrant where it goes, no, that's all right.
I didn't hear you anyway, so it's okay. It's okay. All right, so let's go ahead. We're gonna talk a lot about end behavior. So everyone has it glued down. All right, so we skipped over example 1 yesterday, so I'm gonna give you a couple minutes to copy this down. Okay, so these are actually pretty simple here. So again, your degree is your highest exponent, and what is your degree for part A? What's your highest exponent? 4. And we agree 4 is even. So we agree that 4 is even. Okay, so I'm gonna write that, which tells me that my end behavior is gonna be the same. The leading coefficient is positive, yes.
Why don't we add up the coefficient?
That's a great thing. All right, so the reason why we don't add them is because these are in standard form.
Okay.
So when it's in standard form, we've already multiplied them through, so we can just look at it. Great question. The leading coefficient is the number in front of x to the 4th, which is a 5. And that number is positive. Your y-intercept is always the term that doesn't have an x. So this number here would represent my y-intercept. So my y-intercept is 1, and I'm going to write that as an ordered pair. That's also my constant. These two are the same thing. So because we have the same end behavior, we can write it as one statement. As x approaches positive and negative infinity, f of x is going to do what? Do you think it's going to go up on both sides or down on both sides? Up, because 5 is positive. So we could, so to find the y-intercept, you would substitute a 0 in for all of your x's. When you substitute in a 0, all of these is going to be 0 plus 0 minus 0 plus 1. So your constant is the same as your y-intercept. All right, let's quickly do this side, and then we're going to do a couple graphs, and we'll be finished. Your degree is your highest exponent, which now is 5, and that's odd, which means my end behavior now is opposite. My leading coefficient is a -2. What do you think my y-intercept is going to be for this one? -4. And again, that is the same as my constant. So I'm going to have to write this as 2 end behaviors. So this is your left side. This is the right. So I'll give you a minute to copy them down. So I know I write them pretty fast because I'm used to writing them. So this is the left arrow, and this is asking about the right arrow. We know they're not going to be the same. We know that they're opposite. Excuse me. So my leading coefficient, does everyone see how this time is negative? So that tells me that on the right side it's going to do what? Go up or down? Down. Let's put a negative infinity. Is the left side going to go down also, or is it going to do the opposite and go up? Who says up? Who says down? It's going to go up, right, because it's opposite. And that's your end behavior. All right, the last thing now we're finished with homework 13. Homework 13 is out of the book. It's due Wednesday. Now we're going to start getting into homework 14, which is the worksheet, and that's due Thursday. So let's go ahead and start graphing. Homework 12 we skipped. So we are not doing homework 12 because of time. So we're actually going from 11 to 13. I already updated all of that yesterday. It's all up to date. Canvas is done. All right, go ahead and copy this down. We're going to graph it. What format is this? Is this factor form or standard form? Factor form. And this is the format you want it to be in when we graph. So I'll give you a minute. We have 2 graphs. So yeah, I already made copies of the homework, which is why I didn't, that's why, at first I was going to try to do homework 12, but we really just don't have time for that. And so we're just going to skip over the number 12. It's okay. Go from 11 to 13. So because it's in factor form, your first step would be to factor it. But this one is already factored, so we don't have to worry about that. So now what we're going to do is actually find our x-intercepts. Which are your zeros. So notice how this time we actually have an x. It's not a number, it's an actual x. So these are my 3 factors that I need to set. You need to set all 3 of these equal to 0. This graph has 3 x-intercepts. So you have an x-intercept at x equals 0, If you take the x plus 4 and set that equal to 0, your next one is at -4. And when you take x minus 1 and set that equal to 0, you have one at +1. So go ahead and plot those 3 points. And those are the only 3 places where this function should go through the x-axis. So go ahead and plot that on your graph. I'm going to put a point at -4, a point at 0, and a point at 1. That 0 and 1 are like so close together, but that's okay. So now we need to figure out the degree. So my degree, so I have a 1. I'm going to include that because that's an x on 1. So I'm going to add 1 plus 1 plus 2, which is a 4th degree. 4 is even, so I know that it's going to go in the same direction. Now, looking at this x, is this x a positive x or a negative x? Positive. So what do you think my arrows are going to do? Both sides are going to go up. Good. So I'm going to zoom in really close to the graph. So my x-intercept furthest to the left is -4. I want you to draw an arrow going up. And then also draw an arrow going up from that 1. It's not going to be a pretty graph. It's not pretty. Math is ugly. So we got our arrows. And now we need to figure out, well, what's happening in between here. So what number is directly in the middle of -4 and 0? -2. So let's go ahead and find f of -2. So we need to find our midpoints. So my first midpoint is f of -2. And we're just substituting that right into my function. So that's going to be -2 times -2 plus 4 times -2 minus 1 squared. So type that in your calculator. And you want to type it in exactly the way you see it's written there, with the exponent on the outside. Because what I'm really trying to figure out is this graph, is it going to do something like this where it's going up, or is it going to do something like this where it goes down? What did you all get? -60? All right, so that's a really You know, that's kind of low. We don't have to go all the way down that far. But we just know that in between here it's going to come down. So I when it's ever is a big number like that and it doesn't fit, I just label it. So it's going to come down. It's going to do this. And now we got to see what is it going to do. In between, let me zoom in. So these are pretty close. So what number would be directly in the middle of 0 and 1? A half or 0.5. So let's go ahead and substitute that in. So we have 0.5. Okay, go ahead and type that in. And just, we're going to approximate it. I just really want to know if it's positive or negative because I need to know, is it going to go up and then fall, or is it going to fall and then go up? So I need to know, what is it doing in this little bitty space between 0 and 1? So what does it do? It's going up. What did it hit? About like point, isn't it like 0.6 or something like that? What is it? Okay, so yeah, I rounded it. I remember I said about 0.6. So it just goes up a little bit. So I'm going to zoom in really closely. It's literally just going up a tiny bit and then it's falling back down. It's not pretty. It just hops up a little bit and then it hits back down and goes back and hits the 1. It bounces off the 1 and then goes back up again. All right, and we're going to talk about that again because we knew I knew it was going to do that based off this degree, but we'll talk about that again on Monday. So before we do that, we got one more question and then we'll be done. So let's go ahead and graph this one. This one is not in factor form yet, but it's also pretty easy. So go ahead and copy it down. We have to factor it first and then follow the same 3 steps. So this is a 5th degree. What is the greatest common factor? Because you always start with taking out the GCF. In this example, the greatest common factor is x cubed. So I want you to factor out that x cubed, which is going to give you a quadratic. And then that needs to be factored down again. So unless it's already factored, you have to factor it. So when I factor it down, my 2 numbers that multiply to be negative 12 and add to 1, they multiply to give you negative 12 and add to positive 1. Positive 4, negative 3. All right, so now we're ready for step 1, which is find your x-intercepts. So we have x cubed, set that equal to 0. X plus 4, x minus 3. It doesn't matter how many x's you take out. If you take out 1x, that means you have a 0 at 0, 0. If you take out an x squared, it's still an ordered pair of 0, 0. So this first x-intercept is 0, 0. The second one will be at negative 4, 0. And the last one will be at positive 3, 0. Go ahead and plot these 3 points. So for my end behavior, this is odd and positive. So this is an odd positive function. So because it's positive, when you zoom in, you always start with what is it going to do off this point. So for us, it's 3. So at the positive 3, is it going to go up or is it going to go down? So if it's positive, we all agreed that this was a positive. This is a positive x to the 5th. Because it's a positive x to the 5th, not a negative x to the 5th, I want you to draw an arrow that's rising off of the far, far right intercept. And because it's odd, what do you think it's going to do here? It's going to go what? Down. So now we need to find our midpoints. So we need to plug in some numbers and we're done. I need to figure out what's going to happen in between here. So what number is in the middle of 0 and -4? -2. And then what number is in the middle of 0 and 3? 1.5. So you got to plug in 2 numbers to find your midpoint. You're going to plug in f of -2 and f of 1.5. And it doesn't matter which form you use. You can use the original standard form or you can use the factor form. I'm going to use the standard form though. So I'm plugging in -2 to the power of 5 plus -2 to the power of 4 minus 12 times -2 cubed. See what you get? And then you're going to do the same thing with 1.5. So go ahead and get your 2 numbers. And we're done. I think you get a big number like -80 or 80. I don't know. I'm trying to remember from first period, but I don't remember. I already forgot. What'd you get, Georgia?
For -2, I got 80.
80, positive 80? Okay. And the second one is a decimal. We'll just do it to the 10th. We're just approximating it anyway. So we're not going to count it all the way up to 80. We're not doing that. We don't have time for that. We're going to go to the highest point on our graph and then make a U-turn to come back down. So for my graph, the highest point would be about here. And then I just label it. So my graph is going to come up, hit that point, make a U-turn, and fall back down. And now we need to figure out what is it going to do at the 0. Is it going to bounce off that 0 and go back up again? Or does it go through and then make a U-turn and come back up? It goes down. So what did you get 8 in for 1.5? -27-ish. So we got about approximately -27. So we know it goes down. So I'm going to come down here. I'm going to go down to the very bottom of my graph. It's not pretty, but that's okay. And it's going to look like that. That is really ugly, though. That's a little uglier than normal, but it's okay. That's a real ugly baby. But I still love it, though, because it's my baby. So I'm going to love my baby. For end behavior is the highest power. Wait, okay, ask that question again.
I'm just confused about.
Wait, what? You asked the question about exponent. I just didn't hear that. Can you repeat your question?
Are you adding all of the exponents, even ones you can't see? Or
If
are you
it's
just
in-
taking the highest power in the equation after you factor it?
If it's factored, you add up all your powers. If it's not factored, If it's in standard form, you just look at it and get the highest power.
Submission?
Sure.